it seems we are online now. Engineer Subaya, can you hear me?
Loud and clear.
We can hear you.
Yes, we can. Yes,
Sorry
we
for
can.
the slight delay. We had some technological hiccups. The program is about to start. This evening's presentation is titled Addressing Ghana's Flooding Challenges Holistically, Solving a National Emergency. It is a presentation organized by the Water, Environment and Sanitation Group of the Civil Technical Division of the GHI. We are proud to announce that it is the first technical session for the year 2026. So we want to start the year very hot. We are all welcome. For those of you inside the room, I believe and hope that you know all the protocols. We have a couple of doors on the left. If you need to use the washroom, you can go out there. In case we have to evacuate quickly, there's another door on the right. Ask that everybody calmly proceeds out under the direction of whoever will be in charge at that time. We've wasted enough time, so I just want to introduce our speaker for today, and then he will set the ball rolling. He's Professor Robert Ando, popularly called Bob Ando. He's a technology consultant. He works with AWD Consult Incorporated in Georgia, USA, right? Yes, so Prof comes in every year to talk to us about water and flooding and things. So when the council tasked us to find a way of navigating around these flooding challenges that beset us every year, we approached him and asked him to lead the process. And so eventually he came down at the end of last year and he has agreed to talk to us about what he thinks is the way forward. He's also a member of our institution anyway, though he mainly lives in the US. Those of you who are in water attend our annual water and sanitation conferences. I've interacted with him many times. I just would like to acknowledge the presence of the President of the Ghana Institution of Engineers here with us physically. We also, I just noticed that they passed the executive director to sneaked in somewhere along the line. Aha, he's here. Engineer David and one of our past vice presidents, Engineer Michael Dede, is also here. Is there any other council member I have not noticed? By the way, I'm also a council member. So after all of this, Prof, I think we won't waste much time. We'll hand over the floor to you and then you speak to us, please. All right. Thank you. So we'll give him a round of applause.
Thank you. Thank you. Thank you. Yes, Mr. Chair. And thank you, gentlemen, because I believe, oh, there's a lady here. So ladies and gentlemen, thank you for coming to this evening's presentation. Though we're starting late, I believe we'll have a very fruitful session. I thought I'll start my, you know that the title of my presentation already, but I thought I'll start the presentation by telling you what I'm going to talk about what I'm going to talk about, and then also end on the same note. I'm passionate about what I call policy recommendations. In essence, we have a problem of flooding in Ghana, and increasingly we're seeing that a lot of the major cities, Kumasi, Takoradi, and others are also increasingly being flooded. Accra floods perennially. Anytime it rains. Yesterday, I came from Kumasi, and on the airport road, you know, between the airport and the mall, just a small shower, and the traffic was congested because the flood waters had sort of occupied a couple of the lanes. So it's an issue. It's an emergency in my view. So I think to really address the problem, there's one key issue that we need to bring to bear. I don't believe that we have what I call a post-development flow control policy with related legislation. Because somebody comes in to build a large mall, there's nothing that tells him that he needs to control his flows post-development to pre-development levels. So increasingly, as we keep developing our catchments, we are making the problem worse. So the first port of call, in my view, is we need to initiate a post-development flow control policy. Next on the agenda, in my view, is we need to institute a national rainwater harvesting policy. Not just because rainwater being harvested for potable use. No, we have rainwater needs. We have needs for water, for non-potable water use. For example, we get situations where our fire tenders run out of water. They get to a site, there's no water available. If we had rainwater harvesting, we would have water available locally. That same water could be used for watering our gardens, for washing our cars, and so on and so forth. What's the point in treating water to potable water standards and then using it to wash cars and water flush those? So we need to institute the rainwater harvesting policy, and that will become clear during my presentation. The other thing I think is that we have fragmented institutional arrangements with different institutions responsible for different assets of the water cycle. In my view, we need to establish an integrated urban water utility formulated on a drainage catchment basis. What do I mean by this? We see that a lot of our administrative boundaries are not commensurate with our drainage basin boundaries. So you get a situation where one jurisdiction is responsible for one aspect of the catchment, and that catchment cuts across different jurisdictions. And so there's no integrated way in which problems are addressed. So we need an integrated urban water utility formulated on a drainage catchment basis, which is a statutory consultee for all drainage-related matters. It has responsibility for drainage area plans, flood mapping, forecasting. It needs to be an adequate funded utility. Why do I say this? We have the situation where the Ghana Water and Sewerage Corporation, sewage function never really. Yes, we have Ghana Water and Sewerage, and over time, sewage function never really stopped. And there are issues of funding. That we need to base our funding on tariffs, which are tied into the implemented areas, because the implemented areas are the areas that are responsible for causing the floods. And then we need to spend innovation that drives jobs creation. For example, I will demonstrate a crashed robot cycle, recycled crashed robot tires device for pavement design. So that's just a rundown on what I deem the key things I'd like to address in this presentation. So that if we stop now, you know what I was going to talk about and what I'm. So water is life. We have lived, evolved, and developed most of our major cities around river basins and river bodies. So you take Accra, for example, you have the Odo as one of the major rivers or basins. This is a familiar sight, really, and flooding is not restricted to Accra, Ghana, it's all over the world. But not a so familiar sight is the fact that we have a lot of trash, and in this day and age of kids swimming in trash, that's very deplorable. Now, to really solve a problem, you must understand its origins, sources, causes, evolution, and current state in order to chart more sustainable solutions for the future. So what I want to start by is talk about the evolution of conventional drainage systems and sewage systems. Because once we understand that, it puts in perspective the current situation we face. So the root cause of all of this is the urbanization process. What's the urbanization process? It's taking this kind of landscape where when it rained, it soaked the ground and natural drainage occurred, building on that land. And the way we're building, everybody takes a plot of land and completely builds it right to the boundary of the wall, no space on that lot. And increasingly, we need to have some kind of infrastructure to address the drainage and wastewater issues. And that's the canals and channels that we build for stormwater drainage and the like. The evolution of conventional drainage and wastewater systems has what I call one-dimensional in my view, in the sense that when you look at the history of its evolution, we started off with open channels in places like the UK, and then they had potable water coming to their homes. They connected the wastewater into the open channels, they created problems of smell, so they covered up the open channels. That's how the sewer was born. That open channel then conveyed the water to a water course, and with increasing populations, what happened was the water courses became polluted, and that's how sewage treatment also started. So you realize that it's all in response to a problem that's been observed. We're chasing our tails all the time. When you look at what I call the one-dimensional approach, you realize that the focus has been on the wastewater side. Right. So, for example, on the wastewater cycle side of the equation, the focus has been on the wastewater. That's stormwater becoming. So, for example, in the States, you realize that stormwater control is not just water quantity, but also water quality. So, like I said before, you realize that the issue we face is that the solutions and paradigm governing how we've addressed the problem has been, a feedback control system where we observe a non-desirable effect and we try to do something about it. It's been a fight-flight feedback law. The technologies that have evolved have all been based on reactive, curative problem solving. Let's get rid of nuisance water out of sight, out of mind. And that's how it has resulted in the kind of drainage systems we have and wastewater treatment systems we have. So we need to look at it from a different perspective. But one thing we need to realize is that sewerage systems have made a real difference in our lives. There's this saying that it's done more for mankind in the 20th century than all of medicine. And that's simply because we broke the cycle between humans and their waste. And so sewerage systems have done more for mankind than all of medicine. That's what we really got to realize. So this profession is a very important one. Now, in Europe and places like that, they've evolved their systems, so they have sewerage systems, wastewater treatment, and the like. Now, in the 21st century, in terms of the urbanization challenge of Africa, we have a situation where our open channels are also receptacles of solid waste. So my question to us is, are we going to have to, we're going to have to break the cycle of evolution of conventional systems? And are we going to be in a position to leverage innovations in technology? That's what some of my talk this evening will be about. How we may be able to leverage some innovations in technology to address this very challenge. I say we are going to have to need to move beyond the conventional. What we're going to have to do is we have to address water and sanitation management in an integrated, holistic manner, taking into consideration all facets of the water cycle, including stormwater drainage, wastewater treatment, and also solid waste management. It's really a big challenge. And if we don't do that, there are lessons from the past. For example, you go back to 1665 or thereabouts. That was the last bubonic plague in the UK. And the population of London, about a quarter or so, died or perished in the time of the bubonic plague. We've had a scare in terms of COVID, which is the airborne. but we really had no scale intensive waterborne. But if we had something on the scale of burning plague, Accra has a current population of about 4 million. So you're talking about maybe 1 million people dying, It's very serious, but we take it for granted. And it's real, it can happen. So let's talk about integrated urban water generation. I have what I call simple equations describe management. Rain plus drain equal to pain. What's this all about? When it rains, we have drains that convey the water. And increasingly, as we have more urbanization, the rain plus drain causes pain, which is the flooding that we observe. Why is it so? It's because we've designed based on getting as quickly as possible on the basis of peak flow. So those of you know the fundamental equation that you're familiar with. Q CIA, where C is the runoff coefficient, I is the intensity of rainfall, and A is the drainage area. And your objective is to peak flow and design your system to convey that peak flow away from the area. In some catchments, when the catchment is not highly urbanized, the C, for example, might be at 0.3. When you urbanize the catchment, it becomes about 0.9. So you design a catchment initially to have 0.3 as a C, and that's the flow rate. Now, after you urbanize it and get to 0.9, the flows are decreased by threefold, but your drain has a capacity of, the 0.3. And I think that's the kind of situation we have also in Odo and other places, where initially when the system was designed, Accra was not as well developed as it is now. My equation for addressing the problem is what I call rain plus spin equal to gain. And that is controlling the flows such that you don't inundate your downstream system. So upstream control to address the downstream problem. And there are technologies that can help you address that without moving parts, without power. And that's where the spin comes in. And I'll talk about that in addition to other technologies that are used to address both the quantity side. Some are used for storing stormwater, which you see in those yourself. The flow control is what you see on the left, vortex flow control. And then where you have quality issues, you have filters and the like, but we're not going to go into quality issues, we'll address the quantity. Over the years, I have evolved in my thinking and paradigm. And the new paradigm I think which is needed is that we need to prevent the rain from entering the drain very quickly and take away a lot of the pain. The old paradigm has been based on downstream traditional solutions, which is end of pipe, which results in bigger and bigger and bigger and bigger pipes downstream. The new paradigm is use innovative and efficient technologies upstream, and you get a little gain. So it's upstream control to address the problem. This is where rainwater harvesting comes in, because it's really going back to source. Now let's go back to basics. Those of you who done water have heard about the hydrological cycle. Nature has evolved a balanced hydrological cycle over the millennia, where it rains, percolates to the ground, recharges the aquifer, some of it runs all back into the rivers, and then you get evapotranspiration, and it's a cycle. But in the relative recent emergence of us, the human race on the planet, it becomes such a force of change and influence that we are now impacting and interfering with these cycles on an unprecedented global scale. Our ancestors walked very lightly on the surface of the earth, but we are impacting it in a major way. So what I want to show is water in nature. I think the audio is not coming through. But basically, water in nature refreshes itself through bubbling in creeks and so on and so forth, and getting aerated, re-aerated. So water is life, is a living entity, which we take for granted. And we pollute it with our galamsey and things like that. Swelling motion actually helps to regenerate the water.
Now, there's the concept of what we call the half cycle. In nature, or the balanced hydrological cycle, water percolates into the ground, recharges the aquifer, and the cycle continues. That's a full cycle. But what we've been doing is we've been making our catchments bare in terms of we've been stripping the forest zones. And what that does is that instead of getting the full cycle, we now get what's called a half cycle in the sense that the water runs off quickly into our streams and does not recharge our aquifers. So I believe if we take a close look at our groundwater sources, what we might find is that our groundwater sources are being depleted and not being recharged, and we're getting increasing runoff from our surfaces, causing flash floods downstream. And that's the half hydrological cycle. We're not getting the full cycle because of our urbanization process. So, what's the hydrological effects of urbanization? Like I said before, when you have a green field runoff, you get about 80% of the water actually percolating into the ground to recharge that aquifer, and only about 20% drying off the surface, which is what you see on the top left. But as we urbanize, we flip it in the sense that if you're lucky, about 20% percolates into the ground, now 80% is running off. So the effect of urbanization is after development, you get flash floods or peak flows and increased volumes of flows. Before development, you had a slow runoff response, but post-development, you have much higher runoff response. And we have to develop our infrastructure to address these increased flows. That's why we need bigger and bigger pipes downstream or surface water systems. Here in Africa, I believe our development places unprecedented stresses on our ecosystems, which ultimately, in my view, will challenge our very survival as a species. Looking at satellite images of our coastline, you go back to 1973, our waters along the coastline were very clean. But now, fast forward to the scene, and you see that, you can see a plume of brown, effect of urban sprawl, deforestation, and Galamsey, all visible in space. You look at 1984, around the Takoradi area, you couldn't see the pra, but now you go forward to 2016, and the pra's outline is shown on the landscape. And if you fast forward, I didn't do it for 2025 or 2024, it's even worse. It's all the effect of Galamsey. So the effects are now visible in space. It's a serious issue. The unremitting pace of urbanization is not restricted to us here in Ghana. You take Lagos, for example, 1984. So in the space of one generation, the aerial extent of Lagos such that, it's expanded way beyond its original borders. The same thing is happening here in Greater Accra. When you look at Accra and the built-up areas, you go back to 1943. Accra was of this extent. 1966 it increased markedly. By 2000, Accra developed such that you get in Accra extended all the way, probably I'll say to a break. So this is a serious issue. And then we have issues of flooding, major infrastructural challenges. We go back to flooding that's occurred, this is 2018. We are all familiar with the flood, so I won't make that point here. But the point I want to make is that floods leave many dead in Southern Ghana. It's a serious issue. Lives are lost. And now, increasingly, we're getting flooding in places like Kumasi, Amaga, and near the central market, stuff like that.
So it's a real national issue, There's a tendency for us to just want to live other than, out of sight, out of mind, flooding occurs, and once the rains are over, we say, oh, we don't need to do anything. In Nigeria, Lekki, which is like East Legon, they get lots of flooding. So, Sub-Saharan Africa's particular challenge. In Sub-Saharan Africa, infrastructure development lags significantly behind other developing nations or regions. This, in my view, results in fragmented data service provision, with very limited access to services for Sub-Saharan, largely urban slum populations. Beyond the direct impacts of poor infrastructure, the lack of engineering capacity is also believed to hamper economic growth in several ways. The limited capacity of local providers has led to widespread reliance on foreign engineering contractors. And as an institution, this is a real challenge for us. A lot of major projects are being done by foreigners. And really, it's about time that we step up to the plate. Furthermore, the reliance on foreign firms can result in capital flight and rules potential employment opportunities from the local market. Lack of engineering capacity poses limitations on Sub-Saharan Africa's ability to use abundant natural resources to harness the power of science and innovation to meet development objectives and be competitive in international markets. That's a real challenge because when some of these projects are conducted, there's a lack of transfer of know-how. So we need to keep going back to the foreigners. And that, to me, is a major challenge to us here as an institution. So we have infrastructure that are not fit for purpose because you have a stormwater drain that's full in dry weather. So how can this function as a stormwater drain when it's full of water in dry weather? Then we have drains that are full of sediment and trash. So reduced capacity. How is this going to convey the stormwater? And then we have stormwater drains that go to a dead end. So I followed this on satellite, and then they came to a dead end. So obviously, it's conveying the water into this dump development. So that's one of the challenges we face in terms of the kind of infrastructure we have to do with stormwater. And this is deplorable. It's the low-income neighborhood in Ghana. But before I saw this slide, in my travels, the worst river I'd seen was in India, Bombay. And I thought that was the worst river in the world. But then when I started to see this kind of thing, I believe we also have major challenges in Ghana. So the issue is, how do we find some solutions to this problem or challenge in a cost-efficient manner? And I call this getting more value from less, how it should be done. You remember I talked about my fundamental equation, simple equation, rain plus drain equal to pain, being the source of the issue, and rain plus pain equal to gain being the solution. It goes back to basics. We need to comprehend and copy nature. I take a lot of insight from a guy called Victor Server that he's obviously past an Austrian. And he says that we move things the wrong way. We need to change the direction or reverse the direction. And urban drainage the natural way is a key. What's this all about? It's the principle of prevention rather than cure. And looking upstream rather than downstream. The tendency is to look at where the problem has manifested to address the issue. Instead of doing that, look for preventative ways, look for upstream controls to address the downstream problem. So let's start with the natural system. When systems evolved, we had an undeveloped catchment, that what I call balanced drainage. So you have two sub-catchments combining, let's say the peak flow from that undeveloped catchment on the left is 2 units, the one on the right is 3 units. They combine, give you 5 units. The downstream system has 5 units of capacity. It can handle the rainfall runoff. So there are no issues. That's balanced drainage. But then mankind comes in and we develop the catchments. And then what happens? Instead of 2 units on the left, we now have 3 units because of the development. As we continue to develop, those 3 units might become 5 or 6 or more. The one on the right, instead of 3 units, now we've developed, we have 5 units coming down. But the system, existing system downstream, only has 5 units of capacity. So obviously 3 plus 5 is 8, which is greater than the 5. And what happens then? You get flooding of 3 units, and that's the kind of situation we have where you have the confluence of two catchments with development upstream causing downstream problems. And the conventional solution has been, well, we either need 3 units of storage where the flooding occurs, or we need to increase the size of the downstream system. So it takes one like the Odor catchment. To increase the 8 units means you need to build a bigger drain all the way to the sea, to outlet. That's cost prohibitive. It's impossible to do that. Or you need a big detention system. When you look at the Garrett project, for example, they're looking for detention systems, I think, around the atomic area. So that's to store that 3 units of excess flow so that the downstream capacity can be maintained, the existing 5 units capacity can be utilized. You store the 3 and you have the 5. So that's one way of dealing with the problem. But there are other ways that mimic the natural drainage balance system. The sense that you move further and further upstream. So where you had the 3 units, you put in some controls to attenuate the flows to 2 units. So you have 1 unit of storage there. On the right-hand side, you have 2 units of storage. So you have 3 units coming down. So you've controlled or attenuated the flows to 3 units. They combine, your system can operate on. And that's what we call upstream controls. And these upstream controls can move further and further upstream, such that you can do it at a household level. And this is where rainwater harvesting comes in. So the conventional approach has been based on downstream controls to get rid of the water as quickly as possible, go to a centralized system. And that has been very costly and may not be very effective in terms of the flood resilience. So when you change direction instead of end of pipe approach, you may move upstream to decentralize at small community level, where you have developments, for example, housing developments or housing estates, where once you put in the estate, you control your post-development runoff within the existing capacity. So your housing development has no adverse impact on the overall system. This is why I call decentralized at small community level. This is where we have opportunities to flow control upstream of the catchment. But when you've developed your catchment completely where there's no space for water, then you might have to go to decentralize at the household level. This is where the rainwater harvesting comes in. I believe here in Ghana, particularly in Accra, we've got to the stage where we have no space for water, and we really need to go to a decentralized at source. This is why I'm advocating that we have the national rainwater harvesting policy, because we've run out of space, and I'll come to that in a bit. But this is an output from work I've got one of my students to do, looking at catchments, conventional versus decentralized. And basically what it highlights is that as you move further and further towards the source, your overall costs become much smaller and your system becomes more resilient to flooding, increased flood resistance, and source control being cheaper than the conventional drainage system. What allows you to do this are some of these devices. I won't go into details of them, but you can use them right from drains to rivers. And they control the flows within the capacity of the downstream system. Very large openings. Let's go back. So it's a device that's very passive. It sits there in the drain, and when it starts to rain, it will drain the water downstream, but it will be able to resist or restrict the flows as the pressure increases, what you find is that the shape of the device is such that naturally a vortex will form. So as your rains increase, you get to a stage where in a conventional system, you would have increased the flow downstream. But here, what happens is a vortex is initiated and the spin causes an air pressure, a low air pressure zone. So an air core forms in the device, and that acts as a brake. That's why it's called hydro brake. Naturally initiates just based on the flow regime. So you're limiting or throttling the flows downstream to within the capacity of the existing system. Naturally, without any moving parts, without any need for power. It's all hydraulic. So you can see as the storm intensity increases, it gets to a stage where the vortex becomes a very strong central core, and that's the natural brake. So you don't need automated gates and all those kinds of things. I won't go into details, but this allows you to have much larger openings, so the risk of blockages and so on is very minimized. And it's been used on projects. For example, I'll talk about White Cat, City of Glasgow, the UK, where they had a lot of flooding, pretty serious events since 1908. And the reason was that there are three subcatchments that contribute to flows through central Glasgow. And the conventional solution meant you needed to build levees and embankments and stuff like that, very costly. Some going through railway lines. And looked at it from a different perspective, upstream control to address the downstream problem. They put in flow controls upstream, and you can see the size of flow controls. And you can see the three different flat storage areas where they put in the flow controls to limit the flow going to Glasgow, central Glasgow, to within the capacity of the existing system. And that way, they address the flooding problem in Glasgow. So back to upstream control to address the downstream problem. It's an example of one of the storage areas. So you can see the flow control where it's going. And so basically what you do is you inundate land. This is just post-development, showing that it works, but essentially where you have land upstream, this is under dry weather flow conditions, natural stream, and then obviously use the flow control to limit the flows and mobilize storage upstream. But this is where you have storage ability in terms of this land and space. Here in Ghana, maybe we have some kind of space available at Atomic. I think it's very limited. I believe we're looking for about 600,000 cubic meters or so storage. So it's a proven technology for addressing flooding in terms of flow control. So that's where the rain plus spin equal to gain comes in. In a non-controlled catchment, you get flows coming in and they are uncontrolled. So the downstream sewer is inundated, pressurized. But on the right, with the vortex valve, you limit the flow to within the capacity of the system. You have to mobilize temporary storage upstream that addresses the flooding problem. So let's look at Accra's drainage basin. This is work that we've been doing. I've collaborated in the past with Engineer Francis. We've been talking about this for quite a while. The first time we looked at this issue, we looked at the Odo Basin, but there are several different basins. There's the Tensu, there's the Sakumo, and there are all sorts of basins. But you realize that all these basins have natural drainage channels. But if you look, you see that probably we've developed, and I'll talk about one development later on, but we've developed such that some developments are actually blocking the natural draining paths. So, and obviously that's causing issues with regards to downstream flow and flooding. I looked at addressing the problem of why are we seeing increasing floods in Accra. And the first hypothesis was the rainfall patterns must have changed. We got increasing rainfall, climate change. So I got access to data records starting from the 60s to 2010. And I think this study needs to be extended because we should have more records for. But what I found from that data was that we had a bimodal distribution where we have one major season around about May, June, July, and then another minor season around October, November. And that the rainfall patterns have not changed again. So we cannot blame climate change for what we observe. Secondly, I ranked the rainfall and I realized that the rainfall we've seen in more recent years were not the historical highs. We had events that are much higher than what we see in current times. So Accra can come to a situation where it sees an event that cause major issues with the kind of floods we see now. We're not seeing our historical highs. But the other thing that became interesting as a pattern is in the past, you go for several years without a big flood, maybe 2 years, 3 years. But after 2010, we're getting situations where we get multiple floods in a year. And in more recent times, it's been worse, where we're getting up to 4 or 5 floods in a year. I need to update this, but I'm sure 2024 was no different. We probably had flooded 5 times or more. And looking at the historical records, we realized that it looked like 2010 was a year of significance in the sense that it was after 2010 that we were seeing a lot of flooding, multiple events in a year. And I thought, what happened within the catchment that may have contributed towards this was the project called the Holy Lagoon Environmental Restoration Project, which was completed in 2009 at a cost of 90 million, where we did some recanalization and built an interceptor for trash. And we built some gates at the outlets. And I believe that this may have contributed significantly to the problem we face, in the sense that it reduced the capacity of the outlet, in my view, with those gates. So that's 2010. But also, interestingly, this is work done by Kofi Ako. He's a lecturer currently in the University of Ghana, I believe. He did this as part of his PhD. Looking at the pace of urbanization in the catchment, in the Nodal catchment, 1991, you had only the lower portion of the catchment urbanized. But increasingly, as went to 2002, you see that it's only the Achimota area, and we're moving more and more towards the 2013. We only had the Achimota area, and we're close to Abri. That was 2013. And then I got another student to look and update that and take it to 2020. You can see that, again, he saw similar trends. It says that it's only around the Achimota forest area that's green. And I think what he also looked at was the proportion in terms of vegetation and built up area. And you realize that around about 2010 was when the balance flipped. It says that you had more built up area than green. That's 2020, you had about 70% of the catchment being built up, with only, 20% or 30% being green. At this stage, I'd like to take a short break, if I may. So ponder on this and allow me to contain a water bill.
On.
Hello, those of you online, can you hear us well?
Yeah, we can hear you.
Yes, we can hear you.
Yes, we can.
Yeah, very
Thank you,
clear.
sir. Sure. The presenter has taken a 2-minute break, so we'll be back with you in about 2 minutes, please.
Thank you very much, Chair.
So, okay. Yeah, they can hear.
Well noted.
Okay. If anybody wants to make some comments at this point, you can. You want to make any comments as filling the gap for the creative?
Yeah, Prof hasn't finished yet, but I think how we started, I think our biggest bet in terms of innovations is in the policy area and how we change the way we behave. Because the reactive has always been, let's go and get our money, let's line the order, and then the order gets sealed it. And then we're going to give God one money to come and excavate the silt. We don't know what to do with the silt. But this has been a cycle. But what we are hearing is it's pain because we cannot expand the odor anymore. So if you cannot expand the odor, then that means that we have to act differently. So we probably need to be getting into the mind of government, the people who are making the policy decisions, to start looking at the way we live and the way we manage water right from the household level. And really, it's a slow process. There's no quick fix. We cannot go and build more. And we can do probably demonstrate, pick a small area upstream somewhere and try to demonstrate this or something. But really, this is what I see. And what I see is that it adds up to what the president said. There are so many areas that we do not check. Just look at Ibri going up. Just look at the hill. They are removing all the vegetation. And then there's a lot of silt which comes on the road whenever it rains. All these finally enter the water bodies. Then the issue of siltation comes in. There is unchecked development. The assemblies are the biggest problem. They allow unauthorized development. When we check, sometimes they've given out those lands. He talked about areas that they wanted to put detention ponds. That is one of the biggest challenges that Garrett faces now. The land is inadequate in size. There's been a lot of encroachment, so I don't know how that aspect is going to be dealt with. And many things he said is just a fact because I'm on a project, one of the Garrett components. And let's take Achimota area there, just after the overpass. The Achimota, no, the Apekwa overpass. There's a crossing under the road. The size is fixed. In the past, it used to be okay. Right now, Akwitiman, Achimota, all those areas, we have new drains coming. The drains are now very wide, 7.5 meters wide. That bottleneck is there. I don't know how, when you find money to be able to cut across, even cutting across or bore or tunnel to be able to enter into the section which goes to Alatra. That is and No, what I mean is it will enter the Odo channel, no, which goes through Alaju and enter through the calling. Yes. The reverse fidelity that don't change that call. Let it stay the way.
Grateful music is over, Prophet.
Right, thank you. Yeah, so some of us older gentlemen need to take water breaks from time to time. Those of us of age who understand. Now, this is 2020. We're now in 2026. And given the pace of development, I won't be surprised if, it's now like 90-10. But the way people are building towards a break, it's probably more like 90-10 now. So it's a real challenge. In my view, we run out of space. When we run out of space in highly urbanized catchments, we may need to make room for water by leveraging local storage or going underground. What do I mean by local storage? Local storage is rainwater harvesting. That's why, to me, it's a mandatory national policy that needs to be enacted. That's one of my key recommendations from the beginning. We went all the way upstream to a break. This is just a graphic to depict upstream and downstream. One of the exercises I did, this is going back to 1960 or thereabouts, or 2016, sorry, was I was looking for areas where we may be able to leverage flow control and activation storage. So there's an area view of Greater Accra and zooming in some areas. And then when I looked around, one on the left is the Dinsu, and then you have the Achimota Forest. There was really no space in Accra. It meant you needed to look further upstream. I mean, apart from the Achimota Forest area, there was no green, fully developed off of the Ghana and Achimota. No, there was really no space for water. No space. We've developed the catchment much completely. And even Achimota Forest is subject to encroachment. Give it a chance, have a chance, we'll develop that whole area. So no space for water, really, is what we're faced with in space. Looked at this. And then I went to a place like Ofanko, look back to 2000. Ofanko, in 2000, or prior to 2010, let's put it that way, there was opportunities that we could have done things there. But now, fast forward 2010 and then 2015, completely developed. Every piece of land we find, we need to develop it. We build. Everyone wants to do a project. That's the challenge we face. We made no space for water. That's why I say we need to look at doing something locally. Now that we've run out of space in a highly urbanized catchments, we need to make room for water by going underground. The other challenge we face is blocking of the drainage, natural drainage paths. We build on some of the developments actually build very close to the natural drainage path, which is the floodplain, natural floodplain we build on, and then we block the parts of the development. And that's, I was looking at places like Hacho and so on and so forth. Those places are upstream of the main or north channel, but those places flood. And there are places where when it rains, you can't get home. Because it's ineffective drainage. Once it starts raining, you don't get home quickly. You don't be able to cross and get home. So these are real challenges, very real. And then we have the guide project also addressing the main or north channel and so on and so forth, with upgrading the infrastructure. One of my concerns, I think I came across the current project report, one of the reports. One of my main concerns is that we're spending a lot of money on reinforcing some of the drains. At the service level, we're designing to is 1 in 10 years. And when you factor in climate change, 1 in 10 years might actually become 1 in 5 or 1 in 2. So why go through the expense of bigger, works only for 1 in 10 year level of protection? Typically for floods, you need at least once in a generation, 1 in 35 years, sometimes 1 in 70, 1 in 100 year protection level. So 1 in 10, actually, we as an institution should have been up in arms or uproar saying that that's an adequate level of service for major works in the country. That's what it is. The other challenge we have is our building practices. We're always patient for paving our catchments to our housing completely. You seem to be averse to green. You don't like to see green. For nature, pave everything. And obviously, what's the nature of the response? Just rainfall runoff. Nothing is going to calculate to the ground to recharge aquifers. Everything is going to run off. So here you'll see, instead of being about 0.6 or 0.7, you'll see it's quite maybe 0.99, if not 1. Everything that falls into the rainfall is going to run off. But you go to some of the older developments, you had a lot of greenery, made room for some green. But that's all gone. So when I came and we're talking with the chairman, the institution had an interest in developing a pilot project to do with flooding. And there was talk of a development in Tema, the Traco, which we visited. Engineer Weiss was kind enough to visit with us. He's a very seasoned engineer, the hydro side of things. And we as a country have not been listening to him. I think he's been talking about the need for isolation storage for ages and the need not to develop on floodplains. We've not been listening. But this development had issues with flooding. And we visited and we found out that, in essence, what you have is a situation where the development was, I think, done several years back, in the 90s. And it was okay, there was no problem of flooding then. It's a gated community. But it was developed on the confluence of 2 major drains. Yeah. And then they converted the existing drain within the development. And that's outlying areas developed further and further and further and further. In recent times, 2024, they experienced major flooding. This some of the kind of flood the streets. So there are some housing developments there that have been abandoned because of the extent of flooding. It now floods every time we have a major rainfall. And courtesy of some of the members, I think, of the water platform, we looked at modeling the situation. And you can see the confluence of the lower left, left side. You see the 2 main drains that converge. And the Traco is the hotspot in the middle. And you can see that upstream and downstream of the Traco, there's flooding. So that what this highlights is that no matter what you do within the Traco development itself, you don't address the flooding issue. You either need to make a big infrastructure in terms of a tunnel or something that will convey the flow right away from that entire area downstream, and that will cause the flooding to move or shift further downstream until you go to the river or to the sea, right? And that's because the upstream areas have developed and no space has been made for water. So to me, one of the major solutions with this kind of approach or this kind of problem is if everybody upstream and within the catchment itself goes for rainwater harvesting. That's how you can distribute the storage required across the entire catchment. So the other major works in terms of tunneling and stuff like that, or rainwater harvesting. It's my plea for a national rainwater harvesting policy. And really, when you talk about rainwater harvesting, it's an unharnessed potential for us. This is Nigeria, but it's no different to places in Ghana. The other thing also is that rainwater harvesting has a scope for improving sanitation. Sanitation is the big issue. Now, when you look at these two toilet blocks, which is, more sanitary pleasing. The one that has harvested rainwater has water wash available. So hand washing and stuff like that improves sanitation hygiene. Look at the one on the left. There's no water facility available for washing. So rainwater harvesting on a local basis has the potential to improve sanitation, not just address the flooding issue downstream. So we need to really seriously consider rainwater harvesting. In my view, if we do that, in addition to making water available and access for improved sanitation, I mentioned further earlier on that we had situations where fire attendants get to a site and there's no water available. So if you have rainwater harvesting on a national-wide basis, then water storage will be readily available locally everywhere. And this can help address the challenges faced. So we're going to look at controlling runoff at source and making space for water in our environments. When we do that, we can help start beautifying our landscapes. We don't have, this kind of beautiful landscapes with clean water. But also, it has the potential to spur, innovation and business, because people have to build tanks and the like, for large commercial areas, you need multiple tanks. In the village setting, you could use, earthenware pots to do the storage. Even on the household level, you can incorporate your rain gardens and stuff like that. Have your herbs planted closer to you, vegetables and the like. Incorporate that into your development. But the challenge in Ghana is that you find out that the building has been built such that the actual wall is close to the wall. So there's no space, nowhere to nowhere to put the storage system or device. But seriously, that's something we need to do. And I firmly believe that it has a scope for creating local jobs. And if we have railroad drivers as a policy, and we create an industry based on that, we can export that skill base into the sub-region because we will be the first mover advantage in that sort of sense. We will have all the expertise and know-how in how you manage these kind of systems. So that's my plea for rainwater harvesting across the board nationally. Now, to the other challenge, we have a lot of exposed surfaces. And one of the major challenges we have is erosion or sediment into our drains and channels. And hence the need to dredge the likes of the Odo every year and stuff like that. And when you go to the Wija Dam area, the Densu catchment, there's a lot of erosion. And I believe the Accra Winnipeg Road occasionally has issues or challenges with sediment and so on and so forth. I recall going back in time, this was 2016 when I started looking at the issue of floods in Ghana and what can be done. And I was interviewed by Pulse at the time. And I said the dredging of the Odo was a band-aid. It won't stop the floods. And since that time, they're dredging Odo. It hasn't stopped the floods. So really, we need a different type of solution to the problem. This was the quote of what I said. dredging could not be counted on as a preventative measure to the floods because of the nature of Accra's rains. Come again.
I said that time we were not doing this very often.
Yes. Yes, that's true. It's a much younger version of it. We have a lot of exposed surfaces. The more exposed surfaces you have, the more erosion you will get, which will wash sediment into the drains. Part of this issue is that we need to address and prevent erosion of sediments into the drains in the first place. Dredging is like Band-Aid. Are we going to be dredging every year? At least at the time. This is going back to 2016. I believe we could be very innovative. I believe we could be very innovative in the way we address this whole issue about sediment and dredging and so on and so forth. Because I know as part of the guide project, they're looking at when they dredge the materials, where they put the spoils to landfill and stuff like that. And really, my view is that we could recover that material as, a grit that's been washed. There are technologies that can do that. And we have more than 1 million cubic meters of sediment that can be dredged. This is 1.5 million tons. And we could leverage that as building material or resource. And there's a young Ghanaian guy called Watson. He's got a company called Eco Ghana, and I think Nelplast. And this guy needs to be encouraged and leveraged and replicated across the nation. What he's done is he uses plastics from gutter and beaches, and he mixes that with sand to get paving blocks or building materials. And he's built that house out of the waste, plastics, and sediment. So this needs to be replicated across the nation and encouraged. And really we could then be exporting this kind of know-how, not just in our low-cost or affordable housing projects, but to other countries across the sub-region. The other thing I would like to talk about is something that we could use to address the problem of exposed surfaces. We have what I call porous paving, and you have concrete blocks that are made porous, but there is another technology, porous paving made from recycled car tires. I'd like to demonstrate that. This is the material. It's aggregates from crushed tires, car tires, recycled, and then with a binder. And that can be used for paving. But not only that, but the paving, when it rains, can totally help me with this demonstration. Video. And you were hiding. Oh, so those online to see the demonstration. That's true. Okay, so pour the water. So this is simulating the rainbow. See? So if you have this as your paving material, onto the ground or large car park, right? When it rains, it will soak into the ground. Right. Okay. So you can pass it around to see what it is.
Stamp on it. It's strong.
Yeah, it's strong enough. What you can't do is heavy, like articulated lorries and the like. But for ordinary cars and likely traffic areas, recycled tires. So this is something that our universities can. Right. That's the focus. Thank you. Yeah. Thank you. So this material can easily be adapted for this kind of use and can beautify our catchments. Because if you look at the one on the left and the one on the right, obviously it's more beautiful. It's made from recycled tires. And you know, when you look at the construction, it's easy applied. You know, you don't need heavy plant and equipment, so you can use your local labor, your sidewalks, and so on. Still being hard paved, permeable surfaces can now start to become permeable surfaces. This is what we need to be looking at as part of our developments. Drainage strips, sidewalks, tree surrounds, and the like. So, talk about what I call efficient transformation. We need to go from looking at our catchments as eyesores to something that's pleasing to the eye, and it can be done if we look at incorporating water within our catchments. So part of the vision I have is that when we look at the Odo catchment itself, the Odo channels, that whole area to Nima and so on, become a pedestrian only, enclave, and the water underground, you channel the water in, micro canals, and then the upper surface area can be repurposed for amenity use. How do we transform our local environments? Starting from A, where we have everything paved and running off. Go from A to B, where we start to do rainwater harvesting, at least that's the first step. And then we'll have tree gardens, as you will see, shallow depression areas, swales, and gutters, we have swales, and more planting, greener environment, make space for water, greener environments, and live in tune with nature, rather than what we're doing at A and B. We'll try to go back to C and D. So we need to green environments. But rainwater harvesting is what's going to help us, really. So back to my plea for national policy. So back to my first slide, where I talked about policy recommendations. The first one was post-development run of control, not to exceed development runoff. So somebody, a developer to develop a large estate upstream near Aburi, may do it and increase the flows going on to the Odo. Whereas if you had a post-development run of control policy, putting flow controls and storage, artificial storage within his development to address the problem, so that the impact of his development does not adversely impact the downstream. So that's the first point. And then if we do that, some of the other growing cities, Kumasi, Takoradi, and so on, if these policies are instituted, they won't get to the situation where Accra 2010 was a tipping point. They may have space upstream now, but if we don't do anything now, they'll get to the situation where Accra got to where it ran out of space. Then we need to issue a national rainwater harvesting policy aimed at improving stormwater management and not potable use. I've talked about that. But more importantly, I believe we need to establish an integrated urban water utility formulated on a drainage catchment basis. So that utility has, if it's a Odo basin, has responsibility of the whole of the Odo basin. If the Sakumo basin, it's the whole of the Sakumo basin, so that you can have an integrated approach And they become what I call a strategic consultee for all drain-related matters. So anybody building in that catchment has to have consult them, make sure that their impact of their development is not adverse. They have responsible drainage area plans, flood mapping, forecasting, etc. And it needs to be adequately funded, in my view. So we need to base tariffs on the pavement areas. So if your house is completely paved, 100%, you pay heavy, like not fine, but tariff. If you have more permeable surfaces, so you say your house has only 40% paved and 60% permeable, you pay a different tariff to somebody who has 100% paved, so on and so forth. So polluter pays principle. And then we can spend innovation, things like the recycled tires and so on and so forth, the washing of the sediment to reuse in building and so on and so forth. So, getting to the end of my presentation, but I think we can look at area water management with multiple benefits and look at how we may be able to repurpose the service. The question is, business as usual will not hack it. What will happen if we continue without change? Accra situation will get worse. Accra already is a low-lying area, so we might need to look at just taking the situation as it is and accepting that it's going to flood multiple times every year. It's a situation. But we may be able to do something about it if collectively we embrace rainwater harvesting policy as a national policy. Do something. The question I posed was through innovation approaches, can the developing world default the conventional developmental cycle? I believe we can. If you look at mobile telephony as a case in point, if we still had long lines, the level of telephone penetration would be very low. But now with mobile telephony, everybody has a mobile phone, probably 2 or 3 mobile phones. That's because of the structured technology. Same way with these echo systems, we can have some structured technology. I call them loop infrastructure. Some of them shows that both export control and some of the other systems. There was no time to go into all the details, but there are a lot of technologies that can be leveraged. But also, I believe that there is a need for what I call mindset change, which is where social engineering comes in. Because we need to change some of our habits and some of the things that we do. And we also need to get rid of the culture of dependency, or what I call the aid mentality. We need to go back to our roots, harnessing the rich, immense humanity and intelligence that has traditionally been the African legacy, and reimagining the future. We're in a situation where it breaks my heart to see what we're doing with Galamsey. Really. Our forefathers also mined for gold. But we not destroy the environment in the process. It looks like our generation is doing that at a scale that is unimaginable. The impacts are dire. So what do we need to do? Water is a valuable resource. It should be integrated into our built environment. We don't want to get rid of the water as quickly as possible, which is what conventional drainage has done. We need to hold back the water, reuse it, multiple uses. We need to also bring back the sponginess of the ground, capture and use water at the early stage in its natural cycle as rainfall or runoff. Sponginess of the ground, and example is the crushed recycled tires, porous pavement, bring back the sponginess of the ground. And we need to respect, reduce, recover, reuse, recycle. That's where rainwater harvesting comes in. And if we do that, it's going to help us achieve the Clean Cities agenda through innovation. So again, back to my beginning slide. It's pretty much ends my presentation.
Okay. Thank you very much, Prof, for this very insightful presentation. As is our practice, we will open the floor for comments, questions, interactions whatsoever. And those of you on your line, can you hear me still?
Yes, sir.
Loud and clear.
Yes, we can hear you loud and clear.
Yeah, I can hear you loud and clear. Okay, but we're going to open the floor for questions. How do we know when they want to ask a question? So we'll set up a screen. When we see that your hand is up, then we'll ask you. So we'll start with those of us in house here. Who has a question for Prof, or who wants to add his own ideas to what has been said?
Prof, thank you very much for your inspiring. Yeah, I think you've been advocating for this for quite some time now.
Yes, that's very true.
And I think it's about time the institution, well, if you are part of the institution anyway. So this could be a paper or a position we can take and get it drum home so that the authorities that they will get it really implemented, because I think that's the only solution we have now. And we need to make our voice heard. So, civil check. Well, my name is Engineer David Yante. I'm part of the civil division. And I believe our chair should be able to take this forward and develop it further. Thank you.
It's a comment, right? So he doesn't need to respond right now. So any other comment? Okay, at the end of it. Yes, sir.
Thank you very much. My name is Engineer Richard Ghana. Oh, thank you so much for the presentation. So what we see here is it's because we are able to carry out our drainage project comprehensively. It looks like the resources we have, where we are able to work, we do it and we live it. There is no project that is carried out in terms of drainage that is done 100%. So every time we have issues with our drainage infrastructures. Now looking at the pervious material you showed us, it works perfectly like the concrete subsurface drainage system we do. Now the issue is when the material is applied, depending on the infiltration level. So let's assume that when you've done, I don't know how the process is done anyway. So a percentage infiltrate into the soil. Let's assume that it rains today, it rains the next day, it rains the third day. The whole place becomes saturated, isn't it? So therefore the runoff increases. I mean the overlap flow, yes, becomes a problem. Now, so my question is, how? So depending on the construction, how does it bond with the ground in terms of the material you showed? It's tar, which more looks like rubber. So what is the bonding between the material and then the ground?
I believe you should.
So then the other contribution I want to make here is if we can ask the assemblies to enforce the laws in terms of the percentage of greenery. Now, those that have paved their homes, I can say for a fact that it is we that thinks that we are rich that paves everywhere. The poor people cannot pave their homes. So now, if we can encourage them to do something called retrofitting, so then we are able to take some out, do some greenery, and then allow some level of absorption of the rainfall to reduce floodings. Thank you so much.
Can we take about 2 more so that when Prof starts answering them, he deals with all of them, any of this? Kisi. Jim Kisi, online, could you please pose your question?
Yes, thank you very much, Prof, for your presentation. I'm calling from US, and I'm very happy that Prof has done this presentation. And the question to all of us is that this should be a collective plan and program, because when I was in Ghana in those years, we didn't have this kind of flooding. But over time, with development, it has come to the extent that there is a perennial problem of whereby every year you have flooding and some people are being swept away. And I don't know if the institution has a policy or code whereby any construction, any development requires that that person developing submit something to the authorities to approve before the construction is done. By so doing, you mitigate from one development to the other before it becomes a big problem. Do we have any code, anything that you cannot build until you have been able to show your storm drainage that you are not going to spill it out?
Yeah, if I heard everything correctly, I think the summary of his question was whether there is a code or standard where anyone that wants to develop or undertake any development project has to submit storm water treatment or show that they are not going to impact the next property or the system downstream. That was his question.
Subsequently, for those of you who are online, we are having challenges with hearing you. So if you could please type in your question in the chat box, then we'll read it out and then Prof will address it. Thank you.
Can I address it first? Let me address it first. Before I forget. He contributed in terms of payable payment and stuff like that to ask about the bonding and so on. Normally, what we have is we have another lane of sand as part of the construction of some of these things. The other thing that I can't remember the second point he made. Yes, okay. What we didn't talk about in normal drainage design, you know what's called the major system and the minor system. The minor system is your infrastructure, but really what you don't need to do. So a message that you may have catastrophic events where, let's say, 1 in 50 year, 1 in 30 year event comes. How does your system go? That is your overland flows. So you need to engineer your system so that, for example, your streets, the bypass and so on, act as flood channels in major extreme events. So you need to look at the layer of the land and have what's called the major system and the minor system. So you don't block the flow paths, and you leverage even things like playing fields and so on as major storage areas in extreme events. So those are part of what you need to be a proper design for a system. So there's a major system and the minor system. The minor system needs to move that's less than 1 in 5 years, so on and so forth. The major system deals with the catastrophic events.
Thank you, Prof. My name is Engineer Kansi. My question really is, in the event where you have upstream and source or site controls, and how are you going to manage extreme rainfall? Because certainly you would have designed your system to a certain rainfall event. So basically, otherwise you have the site or the houses flooding as well. Yeah. And just as a comment, Osudoku Hospital has an on-site storm management system that is very interesting. And along the line too, I saw some swales at the Legon Hospital. And this was built way back in 1947. So it's interesting those systems were done back then, and you wouldn't find swales currently among the practices that we have. Yeah, thank you.
Mine is not a question, but I think following on what Engineer Nyante said, I think, Prof, we should be working with Prof to have a hierarchy of solutions. And if we could have a specific pilot, Prof, a specific pilot, because you see, you're able to give us this Google aerial map that shows how things have happened over time. So a breeze coming up, we're taking off all the obstructive slopes. So if we do this paper that we want to forward, and we take a place like Edinburgh, and we show how it is and what we could do specifically. Okay, that there are certain areas that we can use this, absorbent roads thing that we use with tile. Because really, in hydro people, you're doing a major drainage infrastructure plan. So I think that you should find such a thing very interesting. Because what it does is to reduce flash floods, if anything. Okay, because then that is what is happening. You actually delay your runoff, So I think that if we have a hierarchy of solutions for a specific area where we choose an area that is ongoing, and we write it down what could be done, to tie into the solutions that we have hydro doing, that would be very interesting. So
there's a question from Ni Ama's father's book. Ni Ama's father's son, please.
There's a question. Chat.
So we have a question. There are two questions. Jim Kusi spoke earlier. He's asking, do we have a national stormwater mitigation requirement before any development or construction is undertaken? And Peter Yelson is asking, my question is this: upstream water control is the ultimate, but whilst hoping for that to happen, downstream development is fast removing the vegetation and other natural retention areas. So what must be done?
Thank you, Prof. My name is Engineer Benjamin Matete from the Ministry of Works, Housing and Water Resources. Not a question, but a contribution. I saw that you get to the later part of your presentation. I saw social engineering which did not feature much in your presentation. That has to do with human behavior, and I think that contributes a lot to the challenges that we are facing today. So I think we have to look at that. And also to what Engineer Nyante said, and my other colleague, we have to catalog the solutions. The challenges, I'm sure everybody in this room knows the challenges, but the solutions. And we should also be mindful when doing that, we should look at the cost. Because as we are doing, we look at the ones that the cost will be a bit, because the challenges of finances in the country. Thank you.
There were more comments than questions, so I don't recall which ones were the questions. But I know that Jim was asking about other way. That's why, for me, the first port of call is the post-development runoff control policy. And if that is enacted, then the question of downstream developments, we could then actually start to look at enforcing retrofits, and that can help address the problem, maybe. We need a policy that says your post-development runoff cannot exceed your development levels. If that is not enforced in play, then the problem is not being addressed or tackled from a fundamental level. So for me, that's why that's the first point. We need a national consciousness that says our post-development runoff cannot exceed pre-development levels. Talking about a pilot, if we have a variable contractor or developer working in the every areas, we could look at jointly working for a demonstration project which incorporates a lot of these features, such that his post-development runoff does not exceed his pre-development levels, and that becomes a demonstration site. That's a possibility, I believe, if we work together and find the developer who's below the institutional most favorable client, because that demonstration could then be leveraged across the country, in terms of the developer will have benefits, not just in cost, because really, from experience, these upstream control measures, I didn't show examples, but they are more cost effective or cost, beneficial for developers. For example, in the UK, there's a development called Windmill, where typically what they do is, if you have a development, you reserve one of the plots to be your storage, attenuation, detention basin system. So you've lost one plot in the development. But if you do these upstream controls, where industrial for what they do there, they have large sewers in the upstream under the drive of the house to act as storage and attenuation systems, and they have flow controls for each house. So in that sense, you are localizing your storage and spread across the entire development, and then you don't need to have one large pond or detention basin at the end of your development. You are doing it as you construct the houses. Each house has its own attenuation system. And you don't lose the one plot that you would have used for your large detention system. So there are a lot of cost benefits in these kinds of systems. Yeah. Any other questions that may have been answered that I haven't answered? Right. Well, that's why I talked about the major and minor systems. Because really, you need to look at your catchment from a major and minor systems perspective. You need to look at overland flow routes and engineer that as part of your urban landscape. But Engineer Francis has been a colleague, and we run a lot of workshops. He's contributed immensely in terms of local examples of sustainable engineering systems. So,
fresh questions?
He speaks with that, so we should type.
Dr. Kwame Boase, if you could please type your question in the chat box for us. Because when you speak, we can't hear it here. So please.
Yes, engineering, by its deep-rooted value, is to the good of humanity. But in this country, there's one thing I've noticed. Engineers are very quiet. They don't talk. We have the media people making noise all over the place. They say, hey, this must be done. We have the legal profession, they make so much noise, and the authorities yield to whatever they are looking for. And then people turn around to say, oh, engineers are not in, there is flooding now. People will come out and say, oh, it's the fault of the engineers. But in reality, it is not so. So I think we should take a second look at our position when it comes to articulating what we think will be good for the society, for an ordinary Ghanaian. If we can push forcefully, believe you me, and I can tell you on authority that every politician is scared of an engineer, and they know we are quiet, so they make it. Now the second thing is about, I saw the prof talk about age dependence. I can tell you that from now, when the almighty Trump came, he put out USAID. Europe is also talking about using their money for defense. And then just recently,